Alright, welcome back. So we've covered the best news, where we can directly find dimensions of a triangle using the law of sines. We found the worst news, where we can't use the law of sines at all, and we'll have to do something else instead. And that just leaves us with the bad news. The bad news is we've got a situation on our hands that requires a little bit of finesse. A little bit of finesse is required here. But before I explain why, let's just look at what we have. I have a triangle, unsurprisingly, where one of the side lengths is 10, one of the side lengths is 6, and angle C is 33 degrees. So this is where I want to draw this out, drawing the only general triangle that I can. So here's C, that's 33 degrees. This pen does not cooperate well. Side opposite that is 6. And I guess I'll make this be A, and I'll make this be B. So that makes this 10. And such as it's presented, we say, this is achievable. I can find everything in here using the law of sines. I know that because I have the ratio of side C to angle C. I know a ratio, and I have one more unknown. So I can use the law of sines. So let's just jump right into it. I know that B to sine B is equal to C of sine C, and yes, I can flip that over and say sine of B to side B is equal to sine C over C. And so using that, I can solve for now sine of B, because I know C to be 33 degrees, I know lower C to be 6, and I know little b to be 10. So I know everything on this side of the equation, and there's only one other thing to do, and that's to take the arc sine of both sides. And so I've got arc sine of sine, so obviously those cancel, leaving me with b equal to the arc sine of 10 times the sine of 33 degrees all over 6. So I punch that in my calculator, making sure that I'm in degree mode, and I'm able to say, this is 65.19 degrees, give or take. It is a decimal approximation after all, but that's what it is. And, well, you're not wrong, but you're not entirely right either. The issue happened right here. Is it always the case that arc sine cancels sine? And I mean always the case. And the answer to that is no. Arc sine will cancel sine if the angle in question is between negative 90 degrees and positive 90 degrees, which incidentally covers all of the interior acute angles of right triangles, which we've been doing so far, but this is not necessarily a right triangle. So yes, 65.19 degrees is a solution, is a possible value of B, but it's not the only one. Remember how I've said in the last couple of classes that the sine of an angle is equal to the sine of its supplement. Well, that means, for this guy right here, yes, this is true, but the sine of any angle equaling the sine of its supplement means that the supplement of this angle we found, so 114.81 degrees, also works. It also satisfies everything we know, and it works through the law of sines. It is another totally viable construction. So the follow-up question many students will ask me is, well, which is it? Which should I use? And the answer I'll put to you now is both. You have to use both until you can discern that one or either of them is somehow not viable. And that might be the case if this supplement had somehow blown past the budget of allowable interior angles, right? Because I have 33 degrees spoken for in angle C. So if this supplementary angle here had been, say, 157 degrees, which obviously it's not, but had it been, then I know I could have thrown that solution out because 157 plus 33 is already over 180 degrees. But 114.81 and 33 degrees, that comes together to still be less than 180. 65.19 degrees is viable, 114.81 degrees is viable, and we have to treat both accordingly. So here's how I would do it. I would partition out. I would isolate my cases and work each separately all the way down to their conclusion. If I ever reach a contradiction or some issue along the way, that will tell me that I can throw out one of the cases. And if I have to throw out both, I have to throw out both. It's very possible that you have impossible constructions, and that there are no triangles with certain conditions. But here, you're innocent until you're proven guilty. You have to work with everything you have. And so if we assume that angle B is necessarily 65.19 degrees, which it doesn't have to be, but working with this case, we see that A, the remaining unknown angle, has to be 81.81 degrees, subtracting out the other two angles. And using the law of sines now one last time to find the last unknown side, we get 10.9, and some more stuff after that. And yes, that is an answer. If we worked with sine of B, if we worked with B being 114 degrees, 114.8, we get A now being 32.19 degrees, and that's also viable. And so using the law of sines now for 32.19 degrees, we find A to be 5.87. So this set of solutions is also an answer. And both together form the answer. Right? Whenever we're solving a triangle, we're finding all the possible dimensions that satisfy the given conditions. And it just so happens that for the conditions we were given, there weren't one, there were two different constructions that could be made. Let me show you. Let me show you what I mean. I am going to construct both triangles, and they're going to satisfy everything we have. So far, I've got a side of length 10. I know that that side makes, with another side, a 33 degree angle. So I know I've got a side of length 10, and I have to go out some distance on this line, and that's my second side. And I know the third side has to be of length 6. And so that could be any number of things. That could be anywhere from this point extended out by 6. And so the figure we can use to represent everything 6 away from this point is a circle. So I need to make some triangle, which has this side, obviously. It runs along this line until it hits a point that is 6 away from this last spot. And there's two places that happens. The first of which is if we go down and we run over till we hit this spot right here. And then we run up. That's our first option. And you'll see that this is length 10, this is 33 degrees, and if you did the distance formula from there to there, you would find this is a distance of 6. This construction satisfies all the given conditions we had. But that's not the only one. So too does going all the way out to this second point, and then back up. There it is. So there is our second construction. All right, so here's the first, and here's the second. And they are each, in turn, viable candidates. They both fully satisfy what we had to work with. And as such, when we were asked to find all the solutions, all the possible dimensions, both is what we got. That said, though, it's possible that you would have gotten nothing. Right? Suppose we had these things, and I needed the other side to be of length 5. Now we have an impossible construction. Right? I can't run along this line far out enough to ever be exactly 5 away from this spot. So we could possibly have 0 constructions. And had this circle extended to just barely touch this line at exactly one spot, then we would have had exactly one construction. So here's the final thoughts for you. With your ambiguous case, your side-side angle, You have an established ratio, but you don't have two known angles. Your angles are unlocked. That means you have ambiguity, which may be resolved. It may be the case that you just actually have one solution. It may be the case that you have no solutions, and it's an impossible construction. Or it may be the case that you have to account for both. And that's your job. That's what you have to do. So in class, when we're working over these, we'll look at some examples of each of these in turn, get some work on doing all of those, and look forward to that. For now, though, I just want you to keep an open mind, and just instead of assuming that you have to have one single answer, just do the correct steps and see what you get, and see where that takes you. So hopefully that takes you to our next class. Let me know if you have any issues, what you're struggling with most, what you need to look at the most in our next class. And I shall see you then. Have a good one.